Good evening. So welcome to this Meetup talk. So I'm Joe. My full name is Jo-Fai, but you can call me Joe. It's easier. This is like my own story. So how I start from Kaggle to H2O. So hopefully after this talk, you will figure out some way that you can learn online about data science, or things that you can do without actually living your own job. And then maybe you could give your current title and move on to be a data scientist. So that's the main purpose of this talk, to share my experience with you. And there won't be any really technical stuff about Kaggle, but hopefully I will show you enough stuff that about my journey from a total outsider to H2O. Okay, so a quick overview about myself. So I spent the first 10 years of my career in the traditional engineering or water engineering industry, so in both industry and academia. And somehow I discovered H2O and Domino Data Lab. We'll talk about it later in 2014. And I did quite a few things, one led to another, and somehow became a data scientist. So I worked first of all in UK at Virgin Media. It's a telecom company. And at the same time, I have been working for Domino. So working with Moody as a data science evangelist for them to talk about their features, their products. And about last year this time, I joined H2O and become a customer data scientist now. So, agenda of this talk. So the first half is all about the journey. So from total outsider, I was an engineer, and I start to learn something online. Start to try playing with Kaggle or Kaggle in here. Learn some new skills. I did some side projects along the way, and then I found some new opportunities to become a data scientist. And lastly, I discovered H2O and Domino Data Lab back in 2014. At the same time, I want to share with you some of my joyful and sometimes painful experience with Kaggle. And along the way, I met some new friends as well. So then I talk about what are the benefits of actually participating in Kaggle and how it helps me to become a data scientist. And lastly, I want to talk about some tool implementation that I use H2O for. So this is my life before H2O. So I was a data engineer, and you will see this is a data science platform magic project from LondonR. So you can see Domino Data Lab right here. And then we've got H2O over here. So actually all the guys are trying to stream to the top right corner. And then that was me there in the bottom left. I was totally outsider. So you can, in machine learning term, I was an outlier. And outlier. There's no way that I can connect myself to any of those companies right here, about 3 years ago. So what happened? So first of all, back in 2011, I first learned about the massive open online course, so we call it MOOC. This is the first one that I took. So it's the introduction to artificial intelligence. You can heard about this course in different platforms now. It's called Udacity. This is like one of the very first MOOC at the time. So they talk about all the concepts or the theory about AI. They didn't teach any of the programming languages, but it was still very interesting to me to go into a massive online class with lots of students. I think they have like 150,000 people sign up for the course. And the key message I took from Professor President Boon is the way to learn new stuff. How do you learn new stuff? You just dive straight into it and then get your hands dirty, meaning that you want to try something, you want to, even if it's stupid, you want to try something yourself. And don't just wait until someone else will tell you how to do it. And most importantly, I met loads of little fans from the class, so people from US, India, UK, all around the world. So we decided to collaborate. So we want to do something together. So someone talked about Kaggle. So I said, what is Kaggle? So how many of you have heard of Kaggle? If you're here today? Oh, that's good. So I still have to explain it briefly. So it's one of the biggest data mining competition platform right now. So they have different types of competition. So for the red one, there are features with prize. Also there are some recruitment competition, so you can get a job if you go to the top 1 to 10. And there are some playground competition that you can learn from other Kaggle. And also there are some beginners competition. So you can learn from beginners and try to play through the playground and move on to the features competition. So this is the platform that I worked with my friends at that time. So we decided to form a team. So this is my first team at Kaggle. So I didn't know these people too well, but together we want to do something together. So we picked one of the competition at that time is about predicting the trading price of some bonds. So I didn't have any domain knowledge at all. So this is a lot of numbers. By meaning I couldn't open the CSV in Excel. So that's the first try for me. But then I learned a few things about regression models. So random forest, support of the machines, neural networks. So these are all people all new to me. And I was thinking, is it black magic or data science? Still, I wasn't so sure after that competition. I just tried to do something that I learned from others. Then we talk about teamwork. So we have a kind of big team. We want to do things together, right? We don't want to do it alone. But there's a problem. So first of all, it said to me, okay, Joe, you are a really nice guy. So good to have you here. But we can't work together. So I said, okay, yeah, but wait, why can't we work together? And then he said, okay, you're enough with Meetup so much. You love it like you have a fanboy to the handle. That is. So they said they like to use open source tools. They like to use our platform. And I said, okay, maybe you guys can use Update, right? You can use one Meetup code with Update. They said, no thanks, but no thanks. So what happened is that I became the single member in the team who kept working on that conditions. So do it like a lone wolf style. There's zero collaborations at all. And I ended up like 87 of 264 people, which is not bad for the first one. I still think it was okay. But I totally missed out the first purpose of forming a team, which is to collaborate. I didn't. So I think there was a problem with maybe myself. So for dying, if you can't change the world, if you can't change your friends, you have to change yourself, right? So I need to make some changes to myself. So obviously I want to look at what are the skills that I need to do something about it. So first of all, I want to learn about open source programming language. And I want to learn about more machine learning techniques because the random forest supporting the machines, they're all cool, but I didn't really know how they work. So I want to find out more about it. And big data, so how do I scale up my analysis with my very typical laptop at that time? And most important, how do I actually collaborate with others again for real this time? And then kind of way that I want to skill up myself to do more data visualization stuff. So because I was doing photographs in Excel and PowerPoint, I actually just draw the line myself sometimes. But it wasn't really good. So I want to learn something that I can present to other people with a more better way. And I also want to learn about how to explain the results clearly to other people. So where did we start? So I stumbled upon a site called Outlier. Have you heard of Outlier? It's an aggregator of all different sites, really cool. So you can see what people are doing with Out. And they post the projects and all the ideas here, so you can see it. So I have a look and I say, whoa, you can do that with Out. So you can put really nice visualization with just the open source tools out. And then you can do all sorts of different analysis with it as well. So oh, that's very cool. And I really want to want to move on from Excel or PowerPoint to that. So I need to learn. So the first thing I need to do is to find more MOOC, to massive open online course. The first one I did was the other one I did is machine learning by Andrew. So because he used Meetup for that course, so it was easier for me to move on with that course. So I learned some of the techniques, some of the theory again from that. Then I said to myself, I can't use Meetup for update for another project, for another type of project. So I have to force myself to learn Python. So I did take I took the data analysis course by Jeff did, and then the other course, United by Dave did on Python. So I went through that and have a basic foundation knowledge of Python from there. Then you can go through some of the Kaggle forums and you can learn some tricks that you won't be able to learn from books or school. And also I picked up other skills as well. So I was like a Windows guy. I never use other things except Windows. So I learned about Linux, Ubuntu in this case. I also learned about Git. I use Git with the GUI. And about how do I scale up my analysis on Chow AWS. And also learn about how to beautify my projects, so HTML skill and the basic CSS stuff. So Ubuntu is actually like an Asian African word that means I cannot configure it. So that's how I learned Ubuntu. But it's still very cool. So if you try to start with Linux today, I would highly recommend Ubuntu. Okay, here it is. So. And at the same time, I figured out I couldn't just do Kaggle, to learn all the skills. I need to do something extra. I need to do something totally different to Kaggle. So what I did, the first project I want to do is create some beautiful maps. So I picked up one of the data sets from the Open Government Initiative in UK. So they have a street level data set open to everyone. You just use the REST API to draw an area and you get data points from that. So let's create an application. Actually, my parents can use it to visualize some of the crime hotspots in UK. So I created this map. So this is using R with Shiny. How many people have heard of Shiny? Yeah. So it's a really cool tools for you to create web application before learning all the JavaScript. So what I did is to create this app, a blog about it, and sometime later, someone in the US from the Inside Big Data website actually blog about my work. That's cool. So then I move on to the next project. They have a combination from Revolution Analytics before they were part of Microsoft. So they said they want to create a challenge for people to support all the R user group around the world. So I did that with the map, the new CSS in the background, make it look beautiful. And I actually won the competition. And it was really good because it kind of reinforced myself that I have the concept that I'm learning something right. I'm doing something outside my own domain, civil engineering, and I'm doing it right. So then I also want to do something for fun. So this is one of the projects I did totally for fun. So it's about extracting colors from all the pictures. So it's just a very simple k-means stuff. So you get a picture in that, extract all the RGB, that one, do a k-means. It's nothing really special about that, but it's fun. And then some point later, those guys from Revolution Analytics use my package again. This time they analyze the dress. So do you know about the dress? Yeah, how many people think about that as a blue or black? Gold? Right, so I was thinking about gold, okay, but then my own package proved me wrong. So it was actually blue and black mainly. So that's cool. So all this was for fun and translations. So by the time I have a little bit of knowledge about machine learning, so I talked to my friend in Hong Kong and said, hey, I know this thing about machine learning. Random forest for machines. I said, no, you're not doing it right. You're just kidding. You cannot predict the score with all these different random forest for machines. So I said, how about we do a competition? So me against 5 of my friends together. So we want to predict the result of the World Cup 2040. So then I proved to them that I can actually use very simple modeling techniques and some data from different parts of the web. So like the team weighting from different websites, just to create some basic models to predict the score of each match. And I proved them wrong, so I can actually edge them out with some of the machine learning models I created. That's good. So after that, I talked to myself saying, okay, I knew that all these skills are good for me in the long term. I can actually open up myself to maybe more challenges outside civil engineering industry, outside my main domain. And that was the point that I thought I need to become a data scientist. I want to find a job in the data science sector. So that became more opportunity for me to design my work. So first of all, I met a lot of people in the art community. And then I got an opportunity like today to present my requirement at the LondonR. So it's one of the data labs in London, mainly about how to use R for different cool things. And then I got another opportunity to present the same kind of project at Use R 2014. So that is the moment that I went to US to see all the cool guys in our community. So I met different people in Hackney and Earth from our studio, and I also met H2O at that time. That was the first time I saw Amy and Three back there, and Erin as well. She wasn't with H2O at the time, but I saw her talk. And Nick, who was my boss at Domino Data Lab. And Metal is the author of Data Table. I met all these guys, so it's good to be part of the community to share ideas, even though I was like a total outsider. Then comes the opportunity to work with both H2O and Domino. So I emailed Nick, CEO at Domino Data Lab, say, can we use our and H2O on your platform? So, yeah, why not? So I create like a tutorial blog post talking about how to use this technology together for Kaggle competitions. So I didn't know that at the time. This would later on become like a ticket for me to go to Silicon Valley. So this is like my main work on how to change from civil engineering to data science industry. A propose. So then I want to share with you all this different work I did outside Kaggle. I want to share with you my joyful and sometimes painful experience with Kaggle. First of all, for that blog post, I actually did climb up all the way to the first spot. I said, yes, I finally made it. And then I take a screenshot of that, and then that was my only time that I managed to get to the first spot. But I feel really happy about this because it's like very difficult to get to the top spot. You can ask Dimitri, he's a master here. But then comes the reality is that I overfit badly, really massively. So because the score that you can see on the public leaderboard in Kaggle is based on a small portion of the data set. So you may do really well on a small portion of the data set, but you may not do really well enough on the other half or on the other portion of the data set. So that is the first time I feel the fear of overfitting in my life. So, because it was like the feel-good fit. In fact, back in to that report, I was always high up in the top 15. Then later on, I couldn't hold up to 15 and move on to 30. I said, okay, 30 of that, I'm still really good. Let's see. So on the day that I passed the deadline, and then I check, I keep going down and down. I still can't find my name, and all the way down to 500 something. I found, oh, that was me. And that actually was a very valuable lesson to learn at Kaggle, because you can seriously overfit if you don't pay enough attention to your machine learning procedures and techniques. So I got out from that the whole Kaggle experience, and I learned some of the basic exploratory data analysis skills. So how to just look at data, learn more about machine learning algorithm, including H2O and all cool things, HGBoost and other things. Learn some basic feature engineering, how to create some kind of features to help you to get to more to get a better performance. And from Erin, I learned about model stacking, so how you can combine different models together to get get better performance. And most of all, I think the most important thing for me is the communication part. So how do you explain some complex idea, very complex story of your machine learning journey to other people? Then always the last thing that comes to my mind is the fear of overfitting. Again and again, it's like a nightmare. So every time you submit submission to Kaggle, I always fear about the overfitting bit. But sometimes you just can't help. But that's good for you in reality as a data scientist. You don't want to overfit your data set. You don't want to have a generalized model for all your tasks, not just for Kaggle. And then I went to this new, it was new Meetup in London, for London Kaggle Meetup. Met different friends from London, except from Santander, who is from Moscow. But we decided to do Kaggle together, this time using Untitled, so I'm not using that anymore. So this is okay for now. So what I learned from Kaggle is actually very beneficial to my life as a data scientist. First of all, we need to compare some of the data sets that you will find from the class, and then from Kaggle, and from real life. So in class, all the things that they talk to you about data is like a teddy bear. It's like really nice, small. You can open it in Excel. You can give it a cuddle. You won't bite. It's all nice. No missing data. All nice. Then you go to Kaggle. You start to feel that it's like this is big. It's getting bigger. It's a bit scary, but it's still okay. You wait for it. You wait back. It's stable. It's static. It won't change. Then I joined Merchant Media, my first job as a data scientist, and talked to all people about the database, data warehouse in different locations, Scotland, London, everywhere. Then I got this picture. So this is the real world. The data is never clean. There are always some missing data, and there are always some restriction of what kind of data you can get from different databases. So for example, in Merchant Media, you have to talk to different people before you figure out where the data is, and then you have to fill in like 10 pages form to get permissions to get the data. It was a painful experience. But that actually is a good way to use Kaggle as like a primer for you before you actually go into the real world and do the real data set. Because if I start from the top in class data set straight to the real world data set, I'll be totally terrified. Then the other thing is about storytelling. So it's not only about the numbers, it's not about how accurate that you can create a model, how come what kind of production that you can make with your models. It's about telling a story to other people in your organizations or your friends. So they need to understand the value of data, not by understanding your models. You tell them the key message about your data analysis, or you came up from your data modeling stuff. And then the most important part, the most difficult challenge for me during my time at Merchant Media, because we're in a small team working closely with the CFO. So the CFO, he was very busy all the time. So he came out from one meeting, and then he was going to walk to another meeting. So that's the only time we can show him one slide or PowerPoint to explain the key message to him. So that my boss, my manager told me, okay, you have to figure out a way to explain all your ideas, all the key message in one single PowerPoint slide, because you only have like 30 seconds to talk to your CFO, and before he move on to the other meeting. So all the things that I learned before about data visualizations, about how to create an interesting story with some graphics, some numbers, it actually helped me to finish this task. Because without those side projects I did before, I wouldn't be able to explain some of the ideas clearly with some help with graphics and some numbers together in one single PowerPoint slide. And that was really a key for my job to be able to deliver that message in 30 seconds. Okay, so that's all about my experience. I want to share just a little bit of how I use H2O for Kaggle for real. So that's me. I'm not an master yet. I still need to trace one more gold medal. So I want to talk about the two silver medals that I got from Kaggle. The first one is the Rossmann Store Sales. So it's about a regression model, how to try to predict the sales of each individual store. Rossmann is like a pharmacy in Europe. So I team up with the other guy I met from the London Kaggle Meetup, Michael. So we work together, we work quickly, get through to the benchmark, and then we got to top 10%, but we got stuck for a really long time. So what happened is that we almost at the point of giving up, and then he figured out that, okay, maybe we can try to introduce some new data sets, some external data into the model. So he found some way to link the weather data in Germany to the autumn data set, and then we create a model, and we see that there's a massive improvement with that. But then that was like 48 hours before the submission deadline. So because I was the guy who was in charge of the model stacking, so I could do everything quickly. So I built lots of H2O deep learning model, and I stacked it with H2O. It's one of the good gradient boosted machine algorithm out there. This is the live. It was live before I figured out I can do H2O ensemble or stack ensemble in H2O. So I have to do many of the stacking process manually. So it was like a really painful process, but still it worked. We end up at about top 2% when we finished. But that was a good experience to actually collaborate with someone I met from London Meetup. So we become good friends after that. So, and this is the second Kaggle commission that I actually spent more time. So this time I team up again with Chow, but we also met other guys. So Ivan is based in Bristol, one of us in UK. Anarchist, he's like a school kid. He's actually a school kid, 16 years old right now. But he's doing really good at Kaggle. And then his friend set up Turbo, who's in Moscow, so I have to meet him one day in Moscow. So we team up and we try to work on this Santander Product Recommendation together. So the goal for this competition is to predict the new products that a customer will add to their portfolio or the account in the next month. So originally we tried to frame it as like a matrix visualization problem, but the data set was too big for that kind of problem. So we framed the problem as a classification problem, and that we just kind of reduced the data set into a massively smaller size. I can't remember the exact size, but it's manageable with a typical laptop. So we did some basic feature engineering. We tried to do the lab feature. So we say we're taking the products of the customer in the last 5 months and all the other features together with it. So that's the basic features that we found which are the most useful for that. I also asked guys to say, let's speed up the work of our focus on doing the external model, and then they will focus on other features engineering. So try different things, but we couldn't find something really significant and improvement from the advanced features. So we stuck with the basic feature at the end. And I create some H2O GPM models, and after he creates some H2O models. So just do a simple average with those models because we actually merged towards the end of the competition. We didn't have the reverse cross-validation scheme when we try to merge. So we just do a simple averaging. But this is still okay because we didn't actually spend too much time on other stuff. We just do some really quick modeling stuff using H2O. We have about top 3% condition. So these are the two simple methods that with the help of my friends. Again, one of the guidance on the Kaggle master in the forums, and they always share the new ideas. So this is from the website. So it's because of him that we can actually reduce the data set into a very manageable size for the training purposes. So there are many people who keep on sharing ideas in the forum. So it's sometimes I think it's hard for me if you go to a Kaggle forum to find out the best kind of articles. So hopefully there's someone will figure out like an app in iOS or Android to actually just extract the best article from Kaggle and put that all in one place. We also use other tools to help them to collaborate with different people in different cities. So we use Chow. So this is like a dashboard of that is free to use. So you can put on the task that you want to do, the backlog, what you are doing. So people can actually see what you are working on and what have you done in the whole process. So it's easier for us to just share our ideas during competitions. And lastly, this is only for me, so I create like a Google spreadsheet that I record performance or settings within H2O BEng models. And also I make it shareable with my teammates, so they can see actually what I'm doing with my BEng, and they can kind of learn from my BEng setting and see if they can do something else with that. So, and this is I don't usually do this with that many screens in my room. So, but when I Kaggle, this is what I'm like in my room. So I've got the big screen in the back, 2 laptops, and then an iPad. Okay. So the question is, if you want to start today, do you want to do Kaggle or not? I guess Kaggle actually helped me to learn new skills, actually kind of forcing me to realize that I have some skills gap in my career. So I need to improve myself. I need to find something to learn and make sure that I can be ready for future challenges. So learn some new skills. That's quite useful because you don't lose your the domain knowledge. I don't lose my SQL engineering knowledge, but you have keep adding one new skill to your career. And that's good. And you make some new friends along the way. So it's good to talk to people from different backgrounds. So Dimitri said to me that when he formed a team with other Kagglers, our master, the way they think is quite different to him and his father. So it's good to have like a human ensemble. So people from different backgrounds have the same problem from different angles. You often learn from those different kind of opinions. And then there will be always some new opportunities when you have new skills. So for me, it was really lucky to discover H2O and Domino Data Lab back in the time. And also learn one more skill this morning. So say, Giphy is your friend. If you don't have enough time to handle the bullet points, just put a give them in. So I will promise. So, but there's the difference between data science, like pure data science, and Kaggle. So we have like a Slack channel on Kaggle's blog. So we discuss different things about Kaggle. So one of the grandmaster is called Meetup. So I asked him what's the difference between pure data science and Kaggle. So this is the answer I got from him. So to summarize, like the data sets you can get from Kaggle is more like a clean version. So you don't really have to worry about what is the data set beyond your computations. You don't have to figure out the best way to squeeze the information and get the best accuracy on the test set. But that doesn't apply to real time because you can build like thousands of examples, thousands of models to set them together just to squeeze out the performance. But in reality, you have to think about the time constraints, to think about other people, how to replicate the process in the future. There are more constraints in the world of how you can actually evaluate the performance, so how you can define metrics to define success. So there are many differences between Kaggle and data science. But having said that, I still think that if you want to kickstart your data science career, it's good to spend some time to invest in Kaggle, try to learn from other Kaggler, and try to learn other stuff along the way. So thank you for, I want to thank all the people who helped me along the way. So people in UK, English region, gave me the first opportunity to give a talk there. And Domino also gave me the first opportunity to actually step into Silicon Valley with the blog post. H2O gave me an opportunity to work here. And all the friends I met along the way, so they have different, we met at different times of career. So some people were like data scientists already, but some are still trying to figure out what's going on. But together we work, we exchange ideas, we try to help each other along the way. So that was a really good experience in the last 3 years for myself. And so all the slides here and with all the links to my previous project and other articles you can find in our Meetup repository. And if you want to contact me, my email is very easy to remember. It's jo@h2o.ai. I'm still keeping my Molecular's Twitter handle because I'm not going to change it because that's what I came from. And so hopefully you will try to give H2O platform a try after this Meetup because that's actually what helped me to become a data scientist back in 2014. So thank you.
you win any competition?
Hopefully with him. Not yet. Not yet. It's harder, getting harder and harder now. I think I'm still trying to trace my first gold medal. One day.
There's kind of a future where you can get together with teams and form teams.
Yeah, you just
there's
no restriction of forming team with any
it's not
people.
going to be introducing people to other people who are looking for teams. Just hang out with that.
They kind of have the forum to discuss idea, right? So you can actually say, I want to form a team. Is anybody interested? So you can post like a question there and people can get in touch with you.
You also can send a private message to any Kaggle account, like the guy who has a Kaggle account. And if you, let's say, if you're already like a Kaggle novice, I think at least, you can send a private message on that platform. And the person is willing to contact with you, actually, he can respond using his real email. So that's how you can start a conversation.
He's a grandmaster, I should trust him. Yes.
I have one question. Were you working full time when you were preparing for data scientist job?
I was a PhD student at the time. So it's like I did some of the science projects. So it's like the labs or the things. But it was, yeah, I spent extra time working on those because it's totally outside my knowledge, really outside my job. But it was fun. I like it. So yeah, so it's kind of you still have to work on a full-time job. Then for me, it was I really want to become a data scientist at that point. So I need to spend extra effort on it. And then at some point, I know that I will start doing water engineering and move on to data science. So it was an investment.
So how did you manage your time? So you work
You don't sleep. That's it. Yeah, I have a kid. Yeah, you don't sleep a lot, but yeah, it's okay. Yeah. Just don't do it over 10 years, a few years. It's okay. Okay, thank you.
All right, everybody, we're going to do a little switch of speakers. So give me 1 second to switch the screen. Yep. There you go.
Hi everybody, I'm Abhishek Malali. I'm a master's student in computational science at the Institute of Applied Computational Sciences at Harvard. And all my research work, I'll be talking about my research. This is what I'm going to be presenting for my thesis. And all my research is in collaboration with Thomas Prothopapas, who's my advisor and who's also here today, fortunately. So I'm going to be presenting about using deep neural networks for irregular noisy time series. It's kind of a, how would I put it, it's a niche field. Like you don't find irregular and noisy time series in a lot of places. But it's very applicable in the field of astronomy. So why astronomy? Because you can't have telescopes take images, let's say every 30 minutes or every 45 minutes. And you have these huge gaps in the day when you absolutely have no data. So what do you do then if you want to predict? You have these massive gaps. As example here, so this is a Gaussian process, I generate the data, but I have a big gap in the middle where I have absolutely no clue what is happening and what the dynamics of the system are. What would you do currently, right now? Most people convert these irregular time series into regular time series, and then they would do whatever task they want to do. But the problems are that if you have such a case, and if you want to use a simple interpolation method, nothing would work, right? Even if you use a Gaussian process or any other complex method, nothing should work. And you have people trying to use like standard methods like ARIMA, common filters, and Markov models once you convert the data from irregular to regular. But what we are trying to do is keep the data irregular and try to learn as much as possible from the data in order to make better predictions. So why do we use recurrent neural networks? Because these are very powerful and they give you the flexibility to use variable length sequences, which is very important when it comes to using time series. So RNNs have been previously used in text and speech recognition, but if you're dealing with a problem like astronomy where you have very long-term dependencies, recurrent neural networks are not that good a choice. Because when you have a recurrent neural network, so you have a recurrent neural network and you would unroll it, like if you want to open it up in time, then you would have something like this on the right, where you have these blocks, where you have an input for time t, and then you connect it to a block for time t1, t plus 1, and so on. But let's say I want to do backpropagation through time. That's how you learn for recurrent neural networks. So you go from time t, which is like the end, let's say capital T, and you're going back to time when you have the instance 1. And if you're learning and you're propagating gradients, you cannot learn long-term dependencies because of vanishing gradient problem. That is, when you multiply small numbers again and again, you basically have absolutely no updates. So this is why we propose the use of using LSTMs, which is long short-term memory models. So LSTMs are generally much more powerful because you have a concept of a memory, and you don't have these static blocks which are connected in a row. So instead, you have this one block where you have a memory, and the memory is updating itself depending on what input it sees and what the memory was at the previous time step. And again, this is useful to us because you can use it for variable length sequences, much more powerful than recurrent neural nets as well. So this is the network architecture. It's going to be a little hard to read, but I'll go through each one of these blocks. So this is where you have the input. So for LSTMs, the first modification that we had to make was to make it work for irregular time series. And what we did was we actually used the time difference. So we initially started using the absolute value of the time. It didn't make much sense. It didn't work. So we ended up using the time difference. Then we also used the first derivative from the previous time points that we had and the second derivative from the previous time points again to aid the LSTM to kind of predict what the next point will be in a much better manner. So this is the basic LSTM block right here. And I'm going to go through it. So you have the input. So you concatenate the input with the hidden output. So hidden output is the output that your LSTM gives out. And it's the same size as the memory. It might be hard to follow, but please ask me any questions if you have about this. It can be difficult to explain this. And when you concatenate the input here, this is basically a neural network. So you effectively have 4 neural networks in one block. And this is called the forget gate. And what the forget gate is telling you is when you have a new input come in, it's telling you what to forget from the previous memory. Right? You have memory and you have it stored in a vector. And this gate is essentially telling you, forget so-and-so blocks. It doesn't make any sense for me to learn this. And instead, I'm going to update it on with something new on the basis of what data I have right now. So this is the input gate. This tells you which cell state values are going to be updated. So I forgot a few things from memory. I want to learn a few more things. Also, once you know what you're going to update, it's important to see how much you're going to update it by. So you are going to update it here. This is a hyperbolic tangent gate. Again, a small neural network. And it generates the new update values. And this is where you do the update, essentially. So this is where you forgot. And this is where you're learning new things. And this gives you the cell state that goes to the next time point. Now, once you have this updated memory, you're going to use this updated memory along with the hidden output from previous time, then the input at the current time to predict, to actually give a prediction out for the next time step that you want. So this is what is the prediction. It's a hidden output. So let's say I ended up setting the number of hidden output, like the memory size to be, let's say, 100. So it doesn't make any sense for me because I want one number at the end which tells me how good the prediction is. So that would be, if I have a series, I want the next number in the series. So you're going to transform that 100-unit vector into something useful using a feed-forward neural network. So in my case, in all my research, the feed-forward neural network is just a regression layer. So you're just doing weights and bias, and you're converting the output you have, the hidden output you have, into a meaningful output that can be interpreted. So one more thing that we did for the research was that when you have these noisy time series, it's very hard to learn something fruitful out of them and to make the network like generalize over this noise. And what we did was use errors to create new data. So you're essentially doing data augmentation, but you're building like a so let's say I have a series that has all the values and it also has the errors. So it's telling me how much error I have at a certain point. So you're just creating a new data set. So it's kind of learning on the error, and the network learns how to be noise invariant. So that was one of the key things we got out of this. And it essentially predicts better because noise is now completely out of the equation. So these are some of the results. Can you guys see this, or it's going to be, is it hard? So this is a series we're trying to predict. So all this data was synthetically generated. It's an irregular sinusoid with some noise added. And you can see that so these are the residuals, these are the predictions. The same for irregular Gaussian processes. So we wanted to check our robustness on different class of signals. And this is transient signals. So these are signals which suddenly jump. You really don't know when they're going to jump. There is no structure in this. If you look at it, the gap here is larger than the gap here. So we want to see how you would do if you had a stochastic process. And this is on real world data. So this is called long period variable stars. They're variable stars, but they're kind of pseudo periodic. They don't have a very specific period. They don't have a very specific amplitude. They keep changing. So it was a good exercise to be able to use the LSTM approach to predict these. But there's a problem that we see when we use our network is that you see correlation in residuals. So when you have residuals, this is not what you need, because when you have correlation in residuals, that means that you're propagating the error from the previous points. So we wanted to see if we can actually change something in the network to us to make these correlations go down. So I'm going to start with a regular time series, and this would be what the autocorrelation at lag k would be defined as. So you're going to shift the sequence, then multiply, and then normalize it with the actual value of the sequence. So when you have this rho k, you're going to use, so we decided to put that into the loss function. So my initial loss function for the previous network was root mean square error, pretty simple. So what we did was we add a regularization term with phi. So phi is effectively the autocorrelation term now, but it's the autocorrelation of the last n lags. So autocorrelation is bounded between 0 and 1. So if you take, let's say, n lags, you're going to just divide it by n. So this is what phi is. Phi is a normalized autocorrelation for the previous n lags. And you square it, and you add a regularization parameter. Now we wanted to see, does it actually work? So if you look at the results here, when you have lambda is equal to 0, so you still see residuals very clearly here. And when you do lambda is equal to 100, you see absolutely no correlation in the residuals. So this is the starting work on regular time series, and now we kind of figured a way to port this to irregular time series as well. So we modeled the correlation in an irregular time series as an autoregressive process. So autoregressive process is basically, it's going to be hard to explain. So you just have the previous point, and you're trying to predict the next point using a fixed weight, and you add some error. So what we did was to make it work for irregular series. We add this term, that is the power delta t. So that takes care of the irregularity in the series. But as you can see, this is a very complex equation, and the only way you can solve this, so this is residuals basically. So this is a residual at time tj, so, and it is related to the residual at time tj minus 1. So you're trying to quantify this behavior with two numbers, that is phi and sigma. So sigma is basically the noise of your residuals, and phi is the autocorrelation coefficient for your residuals. And if you want to solve this, you need to take the log likelihood. So this is the log likelihood of an AR1 equation. The terms I explained here, so this is the noise, so this is the error, this is the noise again, and so we just took dj as the difference in time. Now if you want to solve this and effectively get one value of phi and one value of sigma, this is what we ended up with, like a board full of equations. And even after doing this for a regular time series, we have a cubic equation which has two constants. So basically you can't solve it, so you have to do it iteratively. And we have absolutely no hope of any solution for irregular time series, especially with delta t in there. So what do we do? So we instead map the log likelihood to the inputs, and you're going to use stochastic gradient descent to come to the right value of phi as well as sigma. So you're learning both of it from the residuals that you have. And in this case, what we did was once the phi is learned, you're going to propagate the gradients back into the network. So this is a little harder if you think about it, because you have to think of it as two networks, where you have a network which is predicting and the other network which is learning autocorrelation constant from the data. So this is how the network looks in TensorFlow. So this is the prediction network. The prediction network is connected to the autocorrelation estimation network, and you can see that the loss comes from both these networks as we defined, which is the RMSE plus the regularization into autocorrelation square. And if you look inside both of these networks, you have a network here which has an LSTM layer, then the regression layer, your output, and in this case, you have the ACR solver which is solving the autocorrelation for you. So some of the additional work that we've been doing is focusing on time series classifiers for variable length sequences. It's an important problem because right now most people standardize time series, and when you slot them, you're going to use interpolation and all these methods. So we're trying to stay away from that, stick with what data we have in order to get the best model or the best results as possible. Also, I'm building a time series machine learning library in TensorFlow. It's called TimeFlow. It's on my GitHub page. And along with this, there's a time series generation library. So all the data that you saw was generated in TimeSynth. So that's what we use for internal testing, as well as if you have a time series, any model, and you really want to check it like very fast, you can just create a ton of data to validate your hypotheses. And all of this work was in collaboration with H2O. And thank you for that, and thank you for giving me the opportunity to speak here. Thank you so much. It's on GitHub and LinkedIn. That's the two things I use. We haven't published this yet, so we're in the process, but soon. Yeah.
You mentioned you look back in time to correlate the residuals. How far do you do?
So we use a lag of 5. So we want to see, like so you can do it for any numbers, right? But it depends on how feasible it is for the network to take out those correlations. So we stuck with a number 5 when we tried doing it for the first 2 autocorrelations. That's the most important. Like you want to take off lag 1 completely, because that says that it's directly correlated with the previous value, which is not a good sign. And we ended up getting negative autocorrelation, which is doing the opposite way around. So even though I don't know what's, so even positive autocorrelation, you already have some error, you're just shifting the error to the other side. So that's why we stuck with using a number like 5, where you have some generality, like the first 2 lags are represented, but you also have a few more lags. So your model is more generalizable, I would like to say.
What if you use a time number, let's say 20, 30, or 50?
Oh, it doesn't generalize. We tried that. So that doesn't work because, yeah, I think it's a problem with how it splits the gradients, and the values of the gradients become really small when it's splitting. So it doesn't reduce lag 1 at all. So it pushes down everything like a little bit, but not enough for me to say that it's success.
Can you use this on any other data?
For this, no. So that is one of the things we want to do once we have all this materialized and finalized. we're looking at other irregular time series applications. So you would see this in transaction data. Definitely. So you can use this for high frequency. Stock market is irregular, but you would have something like high frequency trading data. So that is completely irregular. So there are a lot of use cases for this. And we would love to explore that depending on the time products.
Are you looking for another data set? Because I have one that's pretty well suited for this problem.
Oh yeah, sure.
Yeah.
What's the data set about? I'd love to talk to you about this.
It has to do essentially with different thermal time constants in the system. And you kind of will do an action. Will kind of ripple through your system with 2 or 3 time constants and then get out a result. And you're not quite sure what those time constants are in your system. So your input is varying. It goes through essentially some filtering. You're not quite sure what that filtering is, but you get the input and the output.
Okay, awesome. That seems like something we can talk about. Yeah. Thank you. All right, thank you so much.
Hey everybody, thank you for coming tonight. My name is Ian. I help out with Meetups here at H2O. Feel free to take some pizza, drinks, and we'll have the recording after. Just give me about a day to post it on the Meetup site. Thank you.
So it's training the network to produce decorrelated